Now let's talk about the angular representation of two given vectors, okay, in the vector product. So let's say we have two vectors like this. So let's say this is vector A and let's say this is vector B. We know the cross product, yeah, the cross product of vector A and B will be in the perpendicular direction, okay, to A as well as B, okay, A as well as B, okay. What about the magnitude? Okay, what about the magnitude? Well, that's what the angle is going to come in handy. So let's say this is the angle between the vectors. Okay, so we know in our scalar product also we discussed about this. If two vectors are going like this, okay, we talk about the angle, this angle, not this angle. We don't talk about this angle. We talk about this angle where the arrows are pointed. Yeah. So similarly, in vector product also we do the same thing. Okay, and that will help us to find the magnitude of the given cross product. Okay, so the thing is A cross B, the magnitude of A cross B can be given as magnitude of A into magnitude of B cos sine theta. Okay, this is the interesting part here. Okay, this is the interesting part. Let's do a practice question just to find this. Okay, just to find this. But then we'll look at the observations that we can make, like we did in dot product. Okay, why am I doing so many practice questions in this specific thing? Well, trust me, this is useful. Okay, because when we are going to do questions in planes and stuff, normals are going to be really, really helpful for us to come up with different relationships. So that's why I'm focusing a lot here so that we don't have to spend our time there revising these things. Okay, so let's continue. So this is the basic perspective here. So A cross B will be equal to, we can say I, J, K. So it will be 2 minus 1, 4, 3, 5, and 1. So this will be equal to I into minus 1 into 1 minus 1 minus 4, 4 into 5 minus 20. So it will be minus 21 minus j into 2 into 1, 2 minus 12, so minus 10, and plus k into 10 plus 3, it will be 13. So the output will be minus 21i, k, which is 1i plus 10j plus 13k. Okay, so we can find the angle between these two vectors now. Okay, we can find the angle between these two vectors. So first of all, let's find the magnitude of these vectors. I'll pin the link for the finding magnitude of a vector. You can watch it. So it will be equal to 4 plus 1 plus 16. So that is equal to square root of 21. And we have magnitude of B, that is equal to 9 plus 25 plus 1. That is equal to square root of 35. Okay, and we also know the modulus of A cross B. Okay, so that will be equal to 441 plus 100 plus 169. Okay, so this will be equals to 269 and 269 and 441, 710, square root of 710. So the angle between these two vectors can be found out by using theta is equal to sine inverse. We have, let's write down the equation again. A cross B, the modulus of A cross B will be equals to modulus of A, modulus of B into sine theta. So sine theta can be given as modulus of A cross B over modulus of A into modulus of B. So here we will have square root of 710 over square root of 21 into square root of 35. So this can be given as sine inverse square root of 710 over square root of 735. Okay, so you can use the calculator to find the answer here. So this is the angle between these two vectors. Okay, now let's go to the observations that we can make directly. Okay, so remember the property of vector product. We learned that A dot A cross A is equal to 0. Okay, this is how we can find this out. Okay, this is how we can also find this out. Why? The thing is, A cross A the magnitude of A cross A will be equal to A into sine theta. Okay. And in this case, theta is equal to 0 degree. Okay. So therefore, you will get sine 0. Okay. You'll get sine 0, which is equal to 0. So that's why we can say A cross A is equal to 0. So this is the first observation that we can make. When theta is equal to 0, okay, if the angle between the vectors is equal to 0, we can say the magnitude of the vector product is also equal to 0. Okay, so what happens is, so let's say A is parallel to B. Okay, let's say A is parallel to B, which means it looks like this. We have vector, let me use an arrow. Let's make it beautiful. So let's say this is A and let's say this is B. Okay. So A cross B, the magnitude of A cross B will be equal to 0. Why? Theta is equal to 0 and A cross B is equal to A into B into sine 0. So that will be equal to 0. Okay. So this is an observation that you can make. Okay. That you can make. Okay, so this can also be proved using the normal vector product properties. Why? We know if A is parallel to B, this can be given as A is equals to KB or lambda B. Okay, so A cross B, well, it's yeah, A cross B can be given as KB cross B. Okay, and we know this can be given as K into B cross B. So that is equal to 0. So this is another observation that we can make. Okay, and then if A is perpendicular to B, okay, if A is perpendicular to B, okay, if we have two vectors like this, let's say this is A and let's say this is B. Okay. So what about the magnitude of A cross B? Yeah, what about the magnitude of A cross B? What happens then? Well, let's say this is A. I'll write this down, down. So A cross B, the magnitude of A cross B will be equal to A and B. Because sine 90, since theta is equal to 90 degrees in this case, we can say we can apply the normal equation A cross B is equal to A and B sine 90. Okay. And that will be equal to 1. Since sine 90 is equal to 1, the output will be given like this. Okay. And yeah, these are the observations. Now let's do a tricky question by using the scalar product is as well as the vector product. Okay, so let's say we have let's say they are saying the scalar product. Okay, the scalar product of A dot B is equal to X. Okay, and they are saying the magnitude. Okay, A cross B. The magnitude of A cross B is equal to Y, and they are asking us to find the angle between the vectors A and B. Okay. Well, here you just have to look at the theory that we have learned in the scalar product as well as the vector product. Okay. We know that the theory states A dot B is equals to modulus of A modulus of B cos theta and A cross B, the magnitude of A cross B is equal to modulus of A modulus of B sine theta. And if I divide these two, okay, if I divide these two, and that will be equal to cot theta is equal to A dot B over A cross B. So tan theta will be equals to modulus of A cross B over A dot B. And they're asking the angle between these two vectors. Let's say this is A and let's say this is B. Okay. And they're saying A dot B is equals to X. Okay. A dot B is equals to X and A cross B, the magnitude of A cross B is equals to Y. So this can be written down as Y over X. So theta can be given as tan inverse Y over X. Okay. So this is the question I wanted to focus on. And yeah, let's finish the video here. In the next video, we will look at the area of parallelogram and the area of triangle by using vector product.
Thanks for watching the 25th video in our vector series. If you found this explanation of the angle-related equation for the vector product helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.